everyone. Today we will be looking at how do we find the radius of a sphere. So in our last lesson we discussed finding the volume of a sphere, and we were using the formula 4/3 times pi times r cubed. And the reason why we were looking at r cubed is because remember that a sphere does not have a length, it does not have a width, and it does not have a height. So because it doesn't have those three dimensions, it does have a radius. And so the way that a circle works, or a sphere, which is a three-dimensional circle, it works using the radius cubed. So if we cube that radius, we are able to use the flat spot in the inside of our circle. So if we were to cut this in half and then open it up, we'd have that flat part, which then becomes like a length. And that's how we use the radius. So today we're going to be finding the radius. So they're going to give us the volume of this sphere, so how much can fit inside. But our job is then to use that to isolate the variable for r. And today we're going to be applying our knowledge of cube roots, or taking the cube root, which is to the third power of a sphere. So let's go ahead and get started with our very first problem. And today's problem, our first example, has a sphere. And the sphere, again, we don't know the radius, so that's our job, is to find the radius. It's our three-dimensional model here. Radius is unknown, but the volume, they say that the volume is 288 times pi inches cubed. Okay, well this doesn't tell us anything. We still have to solve here in order to figure out what the volume is. So we're going to multiply 288 times 3.14 to get the volume. So they're asking us to do just a little bit more work before we can move forward with this. So let's use our calculator. We're going to do 288 times 3.14, and that is going to give us a total volume of 904.32 inches cubed. Okay, so what we're going to do now is we are going to rewrite our formula. So the formula that we've been using is the volume of a sphere is 4/3 times 3.14 times the radius cubed. So let's start by filling in the information that we know. So volume, we know that the volume is 904.32. So we're going to fill that in. 4/3 is going to stay as 4/3. Pi is going to stay pi. And our radius, we still don't know radius cubed. So let's go ahead now and we're going to think about isolating this variable. We want to get this r all by itself. So we're going to put a 1 underneath it, and then we're just going to multiply 4 times 3.14. So let's take out our calculator again, and we're going to do 4 times 3.14. And that gives us 12.56, and we want to divide that by 3. Divide it by 3 because 3 times 1 is 3. Oh, okay, that's a big number, right? So we're going to use round to the nearest hundredth, and we're going to go 4.19. And then we still have r cubed. And we're at 904.32. Okay, so now we want to get r by itself. So to isolate this variable, we need to divide by 4.19. This goes away. Divide by 4.19. And that leaves us with r cubed equals 904.32 divided by 4.19. These numbers, I swear. All right, so let's round to the nearest hundredth again. So that gives us 215.88. Whew. All right, now to get rid of this r cubed, we are going to use the square root sign of r, but we're going to put a little 3 there. So we're going to take the square root of the r's. So all of the r's together multiply to equal 215.88. So we're going to take 215.88 and find the cube root, and that is going to give us just one r by itself. So I'm going to move over to the Desmos calculator. And we'll go from there. So Desmos calculator, I think this is really big. I need to make this much smaller, otherwise it doesn't fit in there. All right, so Desmos calculator, we are going to use this, and we're going to put a 3 right there, and we are taking the cube root of 215.88, and that gives us, we can just round that up, 5.99. We can round this up to r equals 6. So this means that 3 r's would be 6 times 6 times 6, and that would get us back to here. So again, we're just using the exact same formula, substituting in what we know. Well, this time around we knew volume. We're solving for the radius because we didn't know the radius. Isolate the variable, and then we could go from there. Okay, all right, now let's go ahead and do another example. Example number 2. It wants us to find the radius of a sphere, example B, and this sphere here. This sphere, that looks like a smiley face. I'm gonna pull this off. Okay, this sphere, we don't know the radius, has a volume of 2,304 times pi. So again, they want us to solve here for the volume. So we're going to 230 times 3.14, and that's going to give us 722.2, and those were cubic centimeters, so centimeters cubed. Okay, so let's use the same formula we used before, but this time we're going to sub in what we know and isolate the variable for what we don't know. So first of all, we know that the volume is 722.2. So volume equals 722.2. I'm going to set this equal to 4 over 3 times 3.14 times r cubed. All right, we're going to solve now for what we know. Again, we're going to put a 1 underneath this so that we can multiply 4 times 3.14. So 4 times 3.14 And that gives us 12.56 divided by 3. See, 4.19. And that is again times r cubed. And we know the 722.2. Okay, now we're going to isolate the variable, so we need to solve for r. So I'm going to divide by 4.19. They gave us the same, I just realized they gave us the same thing. Oh my gosh, Miss Englander. Divide by 4.19. That's really crazy that they gave us the same, oh, no, never mind. Oh my gosh, it's always going to be that because you're multiplying 4 by 3.14. Hello, where is my brain? Okay, so you get r cubed and r cubed. This is where it makes sense now. So this is where the new numbers will come in. Every sphere, when you're looking for the radius, is going to be 12.56 divided by 3, and so on, because that beginning of the formula is the exact same. So now we're going to do 722.2 divided by 4.19. So we get 172.36. Okay, now we're going to do the cube root, because this is really like saying r times r times r. So we want to know what is just 1r. So I'm going to take the cube root of this, switching calculators. And so let's clear this out. And I have 722.2. Oops, what did I do? That is not correct. Cube root, put the 3, now I'm ready. 722.36, and that gives us 8.97, or we could round and just say that 1r is equal to 9. And these are centimeters. 9 centimeters. Okay, it is your turn now for a try it. That came really fast, didn't it? But that's what they have for you in here. So our try it today is going to have you find the radius to the nearest tenth, if necessary, of a sphere that has a volume of 36 pi. So you try it. Has a sphere. We do not know the radius. I feel like these get worse and worse. But the volume is 36 pi. And it is 36 pi meters cubed. Okay, it is hit pause right now so that you don't hear me solving. And then when you're ready, you can come on back and hit play. All right, so first up, we're going to look at 36 times pi because that means nothing to me as a volume. There's some unfinished business there to attend to. So our volume equals 113.04. We have finished the volume business. All right, so we're going to take 113.04. We're going to set that equal to the part that Ms. Englander got confused on. We're going to put this set to 4 over 3 times 3.14 over 1 so that we can solve for r cubed. So draw our balance line so that we can isolate the variable. 4 times 3.14 is 12 point what? 12.56. So this is 12.56 divided by 3, and that gave us a total of what, 4.919? 4.19. Okay, now we're going to bring this down, and we're going to divide. Divide by 4.19, that goes away. 113.04 divide by 4.19. That gives us r to the third power, and we're ready to solve over here. So divided by 4.19, and that equals 26.9 or 27. We want to take the cube root of 27. So the cube root of 27, when we do something times something times something, it will give us 27. But we probably already know, because we've done this one before, that 3 times 3 is 9 and 9 times 3 is 27. But let's double check it just to be safe. 27 cube root, and you get an answer of 3. So r equals 3. And that is 3 meters. All right, how are you feeling about finding the radius? How did that go for you? Go ahead and answer your essential question. How do you find the radius of a sphere? Then put your level of understanding out to the side. If you need some help, come on back to the Google Meet, or you can go on and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.